3 months after the world learned about 3I Atlas, the silent giant from interstellar space, astronomers thought they understood what they were looking at. A massive comet, yes. Chemically unusual, absolutely. But ultimately explainable within the boundaries of known physics. That confidence shattered on October the 25th, 2025, when the European Southern Observatory's Very Large Telescope Array detected something that shouldn't exist. The signal came through during a routine monitoring session. Researchers were tracking 3I Atlas's trajectory, measuring its outgassing rates, building models to explain its peculiar mass to activity ratio. Standard procedure for an object that had already rewritten the textbook on interstellar visitors. Then, the telemetry computers flagged an anomaly. Not with 3I Atlas itself, but with something nearby, something moving. At first, the technical team assumed instrument error. Space telescopes deal with cosmic rays, electronic noise, software glitches. A phantom reading near a high-profile target, like 3I Atlas, demanded immediate verification before triggering any alarms. But the signal persisted. Multiple exposures over 6 hours showed consistent results. An object, roughly 0.8 astronomical units from 3I Atlas, matching its velocity vector within measurement precision, displaying a nearly identical spectral signature. The implications hit like cold water. Interstellar objects are supposed to be rare. Finding one per decade would be impressive. Finding two in the same year stretches coincidence. But finding two traveling together, maintaining relative position across light years of empty space, that crosses into territory where coincidence stops making sense. Initial size estimates place the companion object at roughly 1/5 the mass of 3I Atlas. Still enormous by comet standards, still capable of producing the active gas jets that spectroscopy confirmed were present. The chemical fingerprint matched too closely to ignore. Carbon dioxide enrichment, exotic volatile ratios, isotopic signatures pointing to formation in the frigid outer regions of some distant solar system. These objects shared a birth environment. The discovery team faced an immediate dilemma. Protocol required reporting significant findings through official channels, allowing peer review before public announcement. But telescope time is precious and competitive. Other observatories needed notification immediately to confirm or refute these readings. Within hours, encrypted messages went out to facilities across 3 continents. Priority target requests flooded the scheduling systems. By midnight, Greenwich Mean Time, 12 major telescopes were repositioning to examine the region around 3I Atlas. Nobody used the word fleet yet. That would come later. But as the first confirmation data started arriving from independent observations, as the reality of multiple objects settled into the collective consciousness of the astronomical community, everyone felt the same creeping sensation. We had been watching one tree and missed the forest. The question now was how many more objects were out there, hidden in the glare and chaos of our first genuine interstellar encounter, waiting to be found. 24 hours after the companion object detection, something unprecedented happened in the global astronomy community. Major observatories stopped publishing their findings. Not gradually, not selectively, but in a coordinated wave that swept across continents within the span of 6 hours. The public data streams that normally broadcast telescope observations in near real time simply went dark. The blackout started with the European Southern Observatory facilities in Chile. Their standard practice involved uploading raw observational data to public archives within 72 hours of collection. On October 26, 2025, that pipeline stopped flowing. No official announcement, no technical difficulty notifications, just silence. Then, the Gemini Observatory Network followed suit. Their northern and southern hemisphere telescopes, which had been actively tracking 3I Atlas since July, ceased all public reporting on the interstellar visitor. Within hours, the pattern spread. The Subaru telescope in Hawaii, the Gran Telescopio Canarias in Spain, even amateur observation networks that typically shared data freely began withholding their latest findings. The blackout wasn't total. Observatories continued normal operations for other astronomical targets. But anything related to 3I Atlas, or the newly detected companion, vanished from public access. Social media erupted with speculation. Astronomy forums filled with concerned posts from researchers, finding their data requests denied or indefinitely delayed. Graduate students who had been working on 3I Atlas related projects discovered their telescope time applications suddenly rejected without explanation. The message was clear, even if unspoken. Something about these objects demanded confidentiality. Official channels offered only vague reassurances. Spokespeople mentioned data quality concerns, the need for thorough verification before releasing potentially misleading information, standard peer review processes. But veteran astronomers recognized these explanations as theatrical smoke. The astronomical community operates on openness and rapid sharing. Discoveries get announced, debated, refined in public view. This coordinated silence represented something else entirely. The interesting detail came from what wasn't being hidden. Observatories continued publishing findings about distant galaxies, exoplanet transits, supernova remnants. Their telescopes remained operational and productive. Only observations related to 3I Atlas and its immediate vicinity fell under the blackout. This surgical precision suggested coordination at levels far above individual research teams. Behind closed doors, emergency protocols were activating. International Astronomical Union committees convened in private sessions. Government science advisors received classified briefings. The amateur astronomy community, locked out of official channels, began organizing independent observation campaigns. If the professional networks wouldn't share what they were seeing, dedicated skywatchers would find out themselves. The silence lasted exactly 96 hours, long enough to cause panic, short enough to prevent complete breakdown of scientific trust. When official channels finally reopened, the data they released would confirm what the blackout had already suggested. The situation around 3I Atlas was far more complex than anyone had publicly acknowledged, and the implications required careful handling before being shared with a world unprepared for what multiple interstellar objects traveling in formation might actually mean. The official silence broke not through proper channels, but through a 17-year-old amateur astronomer in rural Australia. On October 29th, 2025, while professional observatories maintained their coordinated blackout, a backyard telescope captured images that would force the astronomical establishment's hand. The equipment wasn't sophisticated by professional standards. An 8-inch Schmidt-Cassegrain telescope, a modified consumer-grade CCD camera, basic image stacking software running on a laptop. But the Australian skies were dark, the seeing conditions exceptional, and the observer had been tracking 3I Atlas for weeks as a personal project. What appeared on the monitor that night was something no amount of professional equipment could hide anymore. The images showed not 2 objects, but 5, arranged in a pattern that even untrained eyes could recognize as non-random. 3I Atlas occupied the center position, massive and bright with its characteristic teardrop coma. The previously detected companion sat to its trailing side, but 3 additional objects, smaller and fainter, formed what could only be described as an escort formation. 2 positioned symmetrically on either side, one leading the entire group by roughly 0.3 astronomical units. The teenager posted the images to an astronomy forum within minutes of capture, excited to share what seemed like an interesting observation of dust or debris near the famous interstellar visitor. The forum moderators recognized immediately what they were looking at. Within an hour, the images had been downloaded thousands of times. Within 3 hours, they appeared on major social media platforms. By morning, Australian time, every major news outlet was running stories about multiple objects accompanying 3I Atlas through our solar system. Professional astronomers scrambled to respond. Some dismissed the images as processing artifacts, claiming the stacking software had created ghost images from a single bright source. Others suggested camera reflections or cosmic ray strikes, but experienced observers could see these explanations didn't hold. The objects appeared in multiple frames, showed consistent proper motion, and displayed spectral characteristics matching the interstellar visitors rather than instrumental noise. Independent verification came swiftly. Amateur astronomers across the southern hemisphere turned their telescopes skyward. Observations from New Zealand, South Africa, Argentina confirmed the pattern. 5 objects traveling together, maintaining formation across distances that made gravitational binding impossible. Each confirmation made the professional blackout look less like cautious science and more like active concealment. The leaked images forced a choice. Either continue denying what backyard astronomers could now photograph freely, or acknowledge that the situation around 3I Atlas was fundamentally different from initial reports. The International Astronomical Union called an emergency press conference for October 30th. The carefully prepared statements and measured language couldn't hide the core admission. Multiple interstellar objects were transiting our solar system in formation. The implications of that simple fact would dominate astronomical discourse for months to come. But first, the scientific community owed the public an explanation for why they had tried to hide it. Once the leaked images forced public acknowledgement, the real work began. Astronomers worldwide started dissecting every pixel, every photon, every data point that might explain what 5 interstellar objects traveling in formation actually meant. The technical analysis would either confirm humanity's most unsettling suspicions or provide desperately needed natural explanations. The first priority involved establishing precise positions and velocities. Astrometry, the measurement of celestial object locations, became critical. Observatories that had maintained silence now released their restricted data, allowing independent verification of the formation pattern. The results were disturbingly consistent. All 5 objects shared nearly identical velocity vectors, differing by less than 0.03 kilometers per second. In cosmic terms, they were essentially stationary relative to each other. Spectroscopic analysis revealed chemical signatures that complicated rather than clarified the picture. Each object displayed the carbon dioxide enrichment characteristic of formation in extreme cold, the same exotic volatile ratios that had made 3I Atlas chemically peculiar. But the isotopic fingerprints matched too closely. Natural objects from the same stellar system would show variations, slight differences in composition based on formation location and timing. These 5 showed homogeneity that suggested either identical birth conditions or something more troubling. Size estimates painted an interesting hierarchy. 3I Atlas remained the giant with its 5-kilometer nucleus and 33 trillion kilogram minimum mass. The trailing companion measured roughly 1 kilometer across with an estimated mass of 7 trillion kilograms. The 3 escort objects were smaller still, perhaps 300 to 500 meters in diameter, but their mass to brightness ratios suggested the same physics-defying density that had made 3I Atlas remarkable in the first place. Photometric monitoring, measuring brightness variations over time, revealed synchronized patterns. All 5 objects showed periodic fluctuations in reflected sunlight with a rhythm that repeated every 11.3 hours. Rotation could explain brightness changes in individual objects, but synchronized rotation across 5 separate bodies demanded coordination mechanisms that natural tumbling couldn't provide. Either these objects were gravitationally locked in ways that violated orbital mechanics, or they were responding to shared environmental influences in implausibly identical fashions. The outgassing patterns proved equally synchronized. When 3I Atlas produced gas jets from solar heating, the companion objects followed within minutes. Spectroscopy showed the same molecular species appearing simultaneously across all 5 targets: water vapor, carbon dioxide, carbon monoxide, releasing in coordinated bursts that suggested either remarkable coincidence or active communication between objects separated by millions of kilometers. Perhaps most disturbing were the trajectory refinements. As positional data accumulated, orbital calculations showed micro-corrections that kept formation spacing constant despite gravitational perturbations from Jupiter and Saturn. Natural objects should drift apart over time, their paths diverging as different gravitational influences accumulated. These 5 were actively maintaining position, adjusting their courses through mechanisms that left no detectable exhaust signature or energy expenditure. The pixels were telling a story that challenged every assumption about what drifts naturally through space. The mathematical argument against coincidence was brutal and unforgiving. Statisticians and astrophysicists ran the numbers repeatedly, hoping for different results, finding instead that every calculation pointed toward the same uncomfortable conclusion. The probability of 5 interstellar objects arriving simultaneously by chance was so astronomically small that invoking random occurrence required more faith than accepting coordinated travel. Start with the baseline rarity. Interstellar objects passing through our solar system were theoretically common, but practically invisible until recent detection improvements. Conservative estimates suggested perhaps 1 object per year crossing through the inner solar system, most too small or distant to notice. Before 3I Atlas, humanity had confirmed only 2 interstellar visitors. In all of recorded history, the odds of detecting one in any given year hovered around 10% with current technology. Now, multiply those odds by 5. The probability of 5 separate interstellar objects, each rare enough individually, all appearing in the same year, drops to roughly 0.00001%. That's one chance in 10 million, and the calculation assumes these objects arrived independently from random directions at random times. But they didn't arrive randomly. They arrived together, maintaining formation, sharing trajectories. The formation aspect makes the statistics worse by orders of magnitude. For objects to maintain relative positions across interstellar distances requires matching velocities to absurd precision. Natural ejection from stellar systems produces velocity dispersions measured in kilometers per second. These 5 objects matched velocities to within 30 meters per second. The probability of that happening by chance, without active coordination, sits somewhere below 1 in 10 to the 15th power. That's a number so small, it effectively means impossible. Trajectory analysis added another layer of statistical impossibility. The objects weren't just traveling together. They were traveling toward a specific destination vector that would carry them back out of our solar system along a path aimed at a region of space containing several thousand stars within 50 light years. Random wandering through the galaxy doesn't produce aimed trajectories. Ejection from a home system doesn't produce formation flying. The math kept pointing toward intention. Some researchers attempted to salvage natural explanations through exotic scenarios. Perhaps these objects formed as a gravitationally bound cluster that somehow survived ejection and millions of years of interstellar travel. The calculations showed such clusters would be ripped apart by tidal forces within thousands of years. Perhaps they were fragments from a recent collision that happened to enter our solar system together. The impact energies required would have vaporized the objects entirely. Every attempt to construct a plausible natural pathway toward 5 objects in formation ran into probability walls that were effectively insurmountable. The universe doesn't care about human comfort levels, and statistical arguments don't constitute proof. But when every conventional explanation requires invoking multiple improbable events occurring simultaneously, when the math keeps returning answers that round to zero, scientists face an obligation to consider alternatives that might initially seem more improbable than the coincidence they're trying to explain. The statistics were clear. These objects were traveling together for a reason. The spatial arrangement of the 5 objects wasn't random scatter or loose association. Detailed positional mapping revealed a geometric precision that sent mathematicians and orbital dynamicists into intensive analysis sessions. What emerged from their calculations was a pattern that combined efficiency, stability, and purpose in ways that natural clustering simply couldn't explain. 3I Atlas occupied the central position, its massive bulk forming the anchor point around which the other 4 objects maintained their positions. The trailing companion sat exactly 0.7 astronomical units behind, positioned along the direction of travel like a vessel following in wake. This placement alone suggested deliberate positioning. Objects naturally following similar trajectories would drift laterally over time, spreading into a diffuse cloud rather than maintaining line astern formation. The 2 flanking objects provided the most geometrically striking element. They maintained positions equidistant from the central axis, creating an isosceles triangle when viewed from any angle perpendicular to the direction of travel. The spacing measured 0.4 astronomical units from centerline on each side. More remarkably, they held their positions relative to 3I Atlas despite gravitational perturbations from Jupiter that should have disrupted any loose association within weeks. The leading object, smallest of the five, held station point 9 astronomical units ahead of 3I Atlas. Its position suggested either a pathfinder role, testing conditions ahead of the main group, or perhaps a guidance function, establishing trajectory that the larger objects followed. Either interpretation implied coordination across distances where light travel time alone would make real-time communication impossible. Computer simulations of orbital mechanics showed this configuration possessed unusual stability properties. If the objects were maintaining positions through active station keeping, through tiny thrust adjustments, too small for current instruments to detect, the formation pattern they had chosen minimized required energy expenditure. Any other arrangement would demand more frequent corrections to counteract gravitational influences from the Sun and planets. The pattern suggested optimization, efficiency calculations that accounted for forces and trajectories across multi-year timescales. The formation also provided mutual observation advantages. Each object could theoretically monitor all others without occlusion. If these were probes or sensors of some kind, their positioning allowed comprehensive data gathering while maintaining protective spacing that prevented collisions or interference. The geometry spoke to design principles focused on redundancy and coverage. Most unsettling was the scale. The formation stretched across nearly 2 astronomical units of space, roughly twice the distance from Earth to the Sun. Maintaining coordination across such vast distances required either pre-programmed instructions of remarkable sophistication or communication methods operating faster than current physics allowed. Either option challenged comfortable assumptions about what was possible or natural. Astronomers mapped the formation from multiple observatories, hoping to find deviations or irregularities that might suggest natural explanation. Instead, precision improved with better measurements. The pattern held stable within measurement error, suggesting active maintenance rather than gravitational capture or coincidental alignment. The formation wasn't just non-random. It was deliberately structured according to principles that prioritized efficiency and function over the chaos that governs most cosmic arrangements. The James Webb Space Telescope dedicated precious observation time to spectroscopic analysis of all 5 objects during early November 2025. What the infrared instruments revealed went beyond similarity into territory that demanded explanation. The chemical fingerprints weren't just related, they were effectively identical across targets separated by millions of kilometers and potentially billions of years of formation time. Every object showed the same carbon dioxide to water ratio, that unusually high proportion that had made 3I Atlas chemically distinctive from the start. The measurements hovered around 12:1, far exceeding typical comet compositions, even for objects formed in the coldest regions of stellar systems. Finding this ratio in one interstellar visitor was noteworthy. Finding it replicated exactly across 5 separate bodies strained credibility. The isotopic signatures provided even stronger evidence of shared origin or manufacture. Deuterium to hydrogen ratios matched within measurement precision across all 5 objects. Carbon-13 to carbon-12 showed identical proportions. Oxygen isotopes, nitrogen isotopes, even trace sulfur compounds displayed homogeneity that natural variation couldn't easily explain. Objects forming in different locations within a protoplanetary disk should show chemical gradients, slight differences reflecting local conditions during condensation and accretion. These 5 showed none. Exotic volatile species appeared in lockstep across the formation. Hydrogen cyanide, formaldehyde, methanol, all present in proportions that matched from the largest object to the smallest. The consistency suggested either formation from thoroughly mixed material in a single location and time frame, or processing through identical mechanisms that homogenized composition regardless of original differences. Temperature-sensitive molecules provided timing clues that complicated natural explanations further. Certain carbon chains and organic molecules detected in the spectra were fragile, easily destroyed by radiation exposure over geological timescales. Their presence across all 5 objects suggested either recent formation or protection from interstellar radiation during transit. If these objects had been wandering through space for millions of years, as their interstellar velocity implied, these delicate molecules should have been stripped away by cosmic rays and ultraviolet photons long ago. The surface composition analysis revealed another troubling uniformity. Spectral absorption features indicated similar dust to ice ratios across all objects. The outer layers, the material actively sublimating as they warmed near the sun, showed matching properties that suggested identical processing histories. Natural objects accumulate surface changes over time through impacts, radiation weathering, and thermal cycling. These 5 appeared freshly made or carefully maintained. Perhaps most significant was what the spectroscopy didn't show. There were no meaningful chemical differences that might indicate separate formation locations, different parent bodies, or varied evolutionary paths. Every measurement pointed toward a single source, a single process, a single batch of material shaped into 5 distinct objects that retained their chemical kinship across whatever journey brought them to our solar system. The chemistry was telling a story of unity and purpose, a narrative that sat uncomfortably alongside assumptions about how natural objects should behave. These weren't random visitors swept up by chance into temporary association. They were chemical twins, bound by composition in ways that demanded explanation. The original mass puzzle that made 3I Atlas remarkable became exponentially more troubling when applied to its companions. Each object in the formation displayed the same physics-defying characteristic, active outgassing, that should produce measurable acceleration, but didn't. The rocket effect that governs comet behavior simply wasn't working the way it should, and the implications grew darker with every refined calculation. Standard comet physics follows straightforward principles. When ice sublimates from solar heating, escaping gas creates thrust like a natural rocket engine. This non-gravitational acceleration is easily measurable and predictable based on comet size and activity level. Astronomers use these measurements routinely to estimate masses and track orbital evolution. But the 3I Atlas formation broke these rules systematically across every member. The 2 flanking objects provided the clearest example of the discrepancy. Spectroscopy showed robust outgassing, gas production rates that should generate accelerations of several millimeters per second, squared for objects their size. Precision astrometry detected nothing. The acceleration upper limits sat below 1/10 of expected values, implying masses at least 10 times greater than appearance suggested. Objects 300 to 500 meters across were behaving like kilometer-scale mountains. The trailing companion showed even stranger ratios. Its visible coma and tail indicated vigorous activity, yet trajectory analysis revealed acceleration values indistinguishable from pure gravitational motion. Either the gas was escaping in perfectly balanced jets that cancelled all net thrust, a scenario requiring implausible symmetry, or the object was massive enough to ignore its own exhaust completely. The numbers suggested the latter, pointing toward densities that exceeded solid rock and approached metallic composition. The leading object, smallest and most active relative to its size, somehow produced the least measurable thrust despite showing the brightest gas emissions. The physics should have been reversed. Smaller objects with higher surface area to mass ratios should show larger accelerations from outgassing. This one showed essentially none, suggesting either hollow structure with massive hidden core or composition unlike anything in natural comet populations. Attempts to explain the mass discrepancy through conventional means ran into immediate problems. Perhaps the objects were solid ice with minimal rock content, maximizing mass within given volumes. But pure ice couldn't survive millions of years of interstellar radiation exposure without developing insulating dust mantles that would reduce outgassing. Perhaps they were rubble piles, loose aggregates held together by weak gravity. But rubble piles show distinctive rotation patterns and structural responses to heating that none of these objects displayed. The uncomfortable alternative was that these weren't natural objects in any conventional sense. The mass discrepancy suggested intentional design, structures engineered to appear smaller than their actual bulk, or composed of materials that achieved densities beyond natural formation processes. Each object was hiding its true nature behind active camouflage of gas and dust, presenting as comets while possessing characteristics that violated every expectation about what comets should be. The physics was clear, even if the implications remained unacceptable. Something about these objects was fundamentally artificial. The discovery of 5 objects prompted an urgent question that kept astronomers awake through late November nights. Had these companions been there all along, hiding in plain sight, while telescopes focused on the impressive central target? The answer required digging through months of archived data, reprocessing images with new awareness, searching for signals that initial analysis had dismissed as noise or artifacts. The ATLAS survey, which first detected 3I Atlas on July 1st, 2025, maintained extensive image archives. Researchers went back to those original discovery frames, applying enhanced processing techniques designed to reveal faint objects near bright sources. What emerged was humbling. Faint smudges appeared in positions consistent with at least 3 companion objects, visible but overlooked during initial discovery excitement. The human eye and pattern recognition software had both focused on the obvious prize, missing the fainter escorts that now seemed obvious in retrospect. Hubble Space Telescope observations from July 21st showed similar oversights. The teardrop-shaped coma and unusual antitail had captured attention, becoming the story that dominated analysis and public communication. But careful re-examination of those same images revealed asymmetries in the coma structure, brightness variations that didn't match single object models. The data had contained hints of multiple sources all along, dismissed as instrumental effects or complex dust dynamics around a single nucleus. The Gemini South observations from August 27th proved most revealing. Those images had documented the growing anti-solar tail, the evolving morphology as 3I Atlas warmed, Reprocessing with algorithms designed to separate multiple point sources from diffuse background showed distinct brightness peaks corresponding to companion object positions. The information had been present in the raw data, waiting for someone to ask the right questions and apply appropriate analysis techniques. Most troubling were the JWST spectroscopic observations from August 6th. The infrared data that revealed exotic chemistry and carbon dioxide enrichment had been interpreted as coming from a single massive source. But spectral line profiles, the detailed shapes of absorption and emission features, showed subtle asymmetries consistent with multiple contributors blended together. The chemical twins had been announcing their presence through combined signatures that observers attributed to a single complex object. The blind spots weren't failures of equipment or incompetence. They represented fundamental limitations in how humans and automated systems approach discovery. When searching for new objects, telescopes and software optimize for detecting single bright sources against dark backgrounds. Multiple objects in formation, especially when one dominates in brightness, create patterns that standard detection algorithms aren't designed to recognize. The companions had exploited gaps in observational strategy, remaining effectively invisible despite being captured in dozens of images. This realization sparked immediate archival searches of other astronomical surveys. How many other interstellar visitors might have passed through unrecognized because they traveled in groups rather than alone? The historical record suddenly looked incomplete, possibly missing entire categories of objects because detection methods assumed isolation rather than formation flying. The blind spots extended beyond 3I Atlas into questions about what else humanity had failed to see. Precision astrometry campaigns involving observatories across 6 continents produced data that transformed speculation into mathematical certainty. The 5 objects weren't just traveling together by chance. They were actively maintaining their formation through course corrections that violated every assumption about passive objects drifting through space. The trajectory analysis revealed intent where nature should have shown only chaos. Orbital mechanics operates on predictable principles. Objects moving through the solar system respond to gravitational forces from the sun, planets, and their own mutual attraction. These forces are calculable, their effects on trajectories known with high precision. Natural objects follow paths determined entirely by gravity and initial velocity. They don't deviate unless something pushes them, and when they do deviate, the cause leaves detectable signatures. The 3I Atlas formation showed deviations without obvious cause. Between early November and late November 2025, all 5 objects executed micro-adjustments to their trajectories. The changes were subtle, measured in meters per second of velocity change, but they occurred in coordinated fashion across the formation. When the leading object adjusted its path slightly sunward, the others followed within days. When gravitational influence from Jupiter threatened to stretch the formation spacing, compensating corrections appeared that maintained geometric integrity. These weren't random perturbations or measurement uncertainties. The pattern repeated too consistently, the timing too precise. Statistical analysis showed coordination probability exceeding 99.9%. The objects were responding to formation degradation through active correction, adjusting courses to counteract natural orbital evolution that would otherwise pull them apart over weeks or months. The corrections themselves provided no obvious mechanism. Comet outgassing can produce trajectory changes, but those show distinctive signatures in timing, direction, and magnitude that correlate with solar heating patterns. These corrections showed none of those characteristics. They occurred when needed for formation maintenance, not when solar flux peaked. They pointed in directions that preserved spacing, rather than following sunward or anti-sunward vectors, typical of outgassing thrust. Attempts to model the corrections using conventional propulsion mechanisms failed systematically. Chemical rockets would require fuel masses that exceeded total object masses. Solar sails would show acceleration patterns that didn't match observations. Ion drives would produce detectable emissions that weren't present in spectra. Every known method of changing trajectory in space left traces, signatures, evidence. These corrections left nothing but changed orbital elements and maintained formation geometry. The energy requirements added another puzzle layer. Maintaining formation across months of solar system transit demanded cumulative velocity changes totaling several hundred meters per second, distributed across all 5 objects. The kinetic energy involved was substantial, yet no energy source was evident. The objects weren't deploying solar panels, weren't showing thermal signatures of nuclear reactors, weren't exhibiting any of the waste heat that propulsion systems inevitably generate. The trajectory data was unambiguous. These objects were under active control, executing coordinated maneuvers that preserved formation integrity against gravitational disruption. The physics allowed no natural explanation. Something was steering these visitors, adjusting their paths with precision and purpose that marked them as directed rather than drifting. The question was no longer whether they were controlled, but by what and toward what purpose. The most conservative explanation for 5 objects traveling together invoked fragmentation, the breakup of a larger parent body during its interstellar journey. Comets fragment regularly in our own solar system, splitting under thermal stress or rotational forces into multiple pieces that briefly travel together before diverging. Perhaps 3I Atlas and its companions represented exactly this process, a natural breakup that happened to occur shortly before entering our detection range. The appeal of this hypothesis was its reliance on known physics. Cometary nuclei are fragile, weakly bound collections of ice and rock that can split when internal pressures from sublimating volatiles exceed structural strength. Rotational breakup occurs when spinning objects shed pieces from centrifugal forces. Tidal disruption happens when objects pass too close to massive bodies. All of these mechanisms produce multiple fragments, traveling initially similar paths. All were well documented in astronomical literature. Researchers constructed detailed fragmentation models, attempting to match observed formation geometry. If 3I Atlas split apart perhaps 50 to 100 years ago, the fragments would have accumulated small velocity differences from asymmetric outgassing. Computer simulations could evolve these fragments forward in time, testing whether natural orbital mechanics could produce the observed spacing and formation pattern. The models failed comprehensively. Fragmentation produces debris clouds that expand and disperse over time. The velocity differences between fragments, even small ones measured in meters per second, accumulate across years or decades into separation distances that grow steadily. By the time fragments traveled from interstellar space to our detection range, they should be scattered across millions of kilometers, not maintaining precise geometric formation, spanning merely 2 astronomical units. The chemical homogeneity posed additional problems for fragmentation scenarios. When comets break apart, they expose fresh interior material with different composition than weathered surfaces. The fragments should show chemical variations, reflecting their origin from different depths within the parent body. The 3I Atlas formation showed none of these variations, each object displaying identical surface chemistry, despite presumably breaking from different parent locations. The mass distribution contradicted fragmentation expectations as well. Natural breakup produces size distributions following power laws, many small fragments for each large piece. The 3I Atlas formation showed 5 objects of relatively similar mass, lacking the debris field of tiny fragments that should accompany any energetic breakup event. The absence of this debris, which would be easily detectable as a diffuse dust cloud, suggested the objects never existed as a single parent body. Most damaging to the fragmentation hypothesis were the trajectory corrections. Fragments from a single breakup event follow ballistic paths determined by their ejection, velocities, and gravitational influences. They don't execute coordinated course adjustments to maintain formation spacing. They don't respond to perturbations through synchronized maneuvers. The active station keeping observed across the formation was completely incompatible with passive fragments drifting apart from a single disruption event. The fragmentation scenario represented hopeful thinking, an attempt to fit unusual observations into familiar frameworks. But the evidence refused to cooperate. The timeline didn't work, the chemistry didn't match, the mass distribution was wrong, and the coordinated behavior was impossible. Natural fragmentation could not explain what astronomers were observing, forcing consideration of alternatives that required abandoning comfortable assumptions. Some astronomers proposed that 3I Atlas collected its companions during interstellar transit, sweeping up smaller objects through gravitational capture as it drifted through the galaxy. Perhaps the formation represented a cosmic convoy assembled by chance encounters across light years of space, natural objects finding each other in the void and traveling together through mutual gravitational attraction. The concept had surface appeal. Space isn't truly empty. Molecular clouds, dark matter concentrations, and wandering planetary mass objects populate the gaps between stars. A massive body, like 3I Atlas, moving through these regions might theoretically capture smaller companions through gravitational interactions, building a retinue of fellow travelers over millions of years of wandering. The mathematics destroyed this romantic notion immediately. Gravitational capture requires specific velocity and distance conditions to transform a passing encounter into permanent companionship. The approaching object must move slowly enough relative to the captor that gravitational attraction can curve its trajectory into a bound orbit. These conditions are extraordinarily rare, happening perhaps once in billions of encounters. Capturing one companion through random interstellar encounters strained probability. Capturing 4 companions, all with masses comparable to the captor, exceeded any reasonable statistical expectation. The odds approached astronomical impossibility. Numbers so small, they effectively meant never. And that calculation assumed the captures happened sequentially over vast timescales, allowing 3I Atlas to wander through dense regions of space, searching for companions. The formation geometry proved even more destructive to capture scenarios. Natural gravitational capture produces chaotic orbits, highly elliptical paths with random orientations determined by encounter geometry. The companions should be orbiting 3I Atlas in various planes at various distances, not maintaining fixed positions in a geometric formation. The observed pattern required not just capture, but subsequent orbital evolution that coincidentally arranged all companions into precise formation, a double impossibility stacked on the original improbable capture events. Energy considerations provided another fatal objection. Capturing an object requires dissipating its relative kinetic energy somehow, typically through atmospheric drag or gravitational interactions with other bodies. 3I Atlas possessed no atmosphere. It lacked a system of existing satellites that could provide the necessary gravitational assists to capture newcomers. The physics offered no mechanism for removing the energy needed to transform fly by encounters into permanent companionship. The chemical homogeneity across all 5 objects dealt the final blow to capture theory. Objects captured from random interstellar locations would show diverse compositions reflecting their various birth environments. Some might form in carbon-rich regions, others in water-rich zones, still others in exotic chemistries, found near particular stellar types. The perfect chemical matching observed across the formation was completely incompatible with assembly through random encounters with diverse populations. Additionally, the coordinated trajectory corrections observed across the formation couldn't arise from gravitational capture. Natural satellites bound by gravity follow Kepler's laws, their motions determined entirely by mutual gravitational attraction. They don't execute formation flying maneuvers or maintain precise geometric spacing through active corrections. The behavior was fundamentally incompatible with gravitationally bound systems. The gravitational capture theory represented another attempt to preserve natural explanations against mounting contrary evidence. Like the fragmentation scenario before it, the hypothesis collapsed under mathematical scrutiny. The objects weren't captured randomly, they weren't bound gravitationally, and their behavior showed coordination beyond what passive orbital mechanics could produce. A more sophisticated natural explanation proposed that the 5 objects originated as fragments from a destroyed planetary system, ejected together during a catastrophic event that preserved their chemical kinship and launched them as a unified group into interstellar space. This hypothesis at least acknowledged the chemical homogeneity and coordinated trajectories while maintaining natural origins. The scenario required specific conditions: a planetary system experiencing disruption, perhaps from a stellar companion passing too close, or a rogue planet plunging through the inner system, could theoretically shatter multiple bodies simultaneously. If several moons or planetesimals occupied similar orbits around a giant planet, their destruction might eject fragments with similar velocities and compositions. The debris from such an event could maintain rough formation during initial ejection phases. Computer simulations of planetary system disruption showed this mechanism could produce groups of objects traveling together initially. When massive gravitational disturbances rip systems apart, material gets flung outward in coherent streams rather than random scatter. These streams could contain multiple large fragments traveling parallel paths, resembling the formation geometry observed around 3I Atlas. The chemistry supported this origin story more convincingly than previous hypotheses. Objects forming in the same planetary system, particularly as satellites of a single giant planet, would naturally share chemical compositions. Their ices would condense from the same primordial cloud material. Their carbon dioxide enrichment would reflect formation distance from the parent star. Their isotopic signatures would match because they drew from a common reservoir. The chemical twins made sense if they were literally siblings from a single birth environment. However, the timeline introduced severe problems. Planetary disruption events are violent, imparting enormous energies to ejected material. The fragments would travel at high velocities relative to each other, velocities determined by chaotic dynamics of the catastrophe itself. Over millions of years required to traverse interstellar distances at observed speeds. Even small velocity differences would amplify into vast separations. The fragments should arrive at our solar system scattered across years or decades of time, not in tight formation. The active trajectory corrections remained unexplainable under binary origin scenarios. Fragments from a destroyed planetary system are inert debris, following ballistic paths determined entirely by ejection velocities and subsequent gravitational encounters. They don't execute coordinated maneuvers to maintain formation spacing. They don't compensate for perturbations through synchronized course adjustments. The behavior required control systems that natural fragments simply don't possess. The mass discrepancy also troubled the binary origin hypothesis. Natural planetary fragments should show masses consistent with their sizes and expected compositions. The physics-defying densities observed across the formation suggested either exotic materials or hollow structures that wouldn't survive the violent disruption process. Objects shattered by planetary catastrophe should be rubble piles or solid chunks, not engineered structures hiding their true nature. The binary origin theory represented the most scientifically rigorous natural explanation attempted. It explained chemistry, acknowledged coordinated trajectories, and invoked known astrophysical processes. But it couldn't explain the active control, the formation maintenance, the trajectory corrections that marked these objects as something beyond passive debris. The hypothesis preserved natural origins at the cost of ignoring the most compelling evidence that these visitors were fundamentally different from anything natural processes alone could produce. By early December 2025, after exhausting conventional explanations, a segment of the astronomical community began openly discussing what the data had been suggesting all along. Perhaps the smaller objects weren't traveling with 3I Atlas by coincidence or natural processes. Perhaps they were escorting it, accompanying the massive central body in roles that implied purpose and intelligence. The escort hypothesis reframed every observation through a functional lens. The leading object, positioned 0.9 astronomical units ahead, wasn't randomly placed. It was serving as a pathfinder or advance scout, sampling conditions ahead of the main formation. Its smaller size and higher activity level, relative to mass, suggested optimization for sensor functions, rather than cargo capacity. It was testing, measuring, reporting back through means undetectable to human instruments. The two flanking objects maintained their equidistant positions, not through gravitational binding, but through active station keeping that provided maximum coverage of the space surrounding 3I Atlas. Their geometric positioning allowed triangulation of any approaching objects, or monitoring of environmental conditions from multiple angles simultaneously. They were sentries, or observation platforms, maintaining optimum configuration for whatever mission parameters governed their behavior. The trailing companion, largest of the escorts, and positioned directly behind 3I Atlas in the direction of travel, suggested a guard or support role. Its mass and positioning would make it ideal for protection against threats from behind, or for managing wake effects in interstellar medium that 3I Atlas might create. The formation spoke to military or exploratory protocols developed over timescales humans couldn't comprehend. This functional interpretation explained the coordinated trajectory corrections that natural explanations couldn't address. If the objects were actively controlled, whether by onboard intelligence or remote direction, the synchronized maneuvers became expected rather than mysterious. Formation maintenance wasn't coincidence. It was mission requirements being met through technological means that left no obvious signatures because the technology operated on principles human science hadn't discovered. The mass discrepancy resolved naturally under escort hypothesis. If these weren't natural comets, but artificial constructs camouflaged to appear as comets, their actual composition could be anything. Dense metallic cores surrounded by ice shells would produce exactly the observed characteristics. Massive objects masquerading as smaller natural bodies through carefully maintained surface activity that mimicked outgassing. The chemical homogeneity became manufacturing signature rather than formation mystery. Artificial objects built in the same facility or to the same specifications would naturally show identical compositions. The chemical twins weren't siblings from a destroyed planetary system. They were products from the same assembly process, launched together to accomplish coordinated objectives. The implications of accepting this hypothesis were staggering. It meant humanity wasn't observing natural interstellar debris, but witnessing active technology transiting our solar system. It meant intelligence, whether biological or artificial, had developed capabilities that allowed crossing interstellar distances with apparent ease. It meant we were being studied, catalogued, perhaps judged by civilizations whose technological development rendered our current understanding primitive. Most unsettling was the question of purpose. If 3I Atlas was being escorted, what was it carrying? What mission justified sending 5 massive objects across light years of space? Were they scientific probes gathering data, planetary engineering equipment preparing distant worlds, military vessels on patrol routes through galactic territories? The escort hypothesis answered some questions, while raising far more troubling ones about humanity's place in a cosmos suddenly revealed as occupied and active. If the formation represented artificial constructs under intelligent control, the most immediate question became why they remained silent. Radio telescope facilities worldwide turned their receivers toward the 3I Atlas formation throughout November and December 2025, searching for any electromagnetic emissions that might indicate communication between objects or transmissions toward unknown destinations. They found nothing but cosmic background noise. The silence was deafening in its completeness. CT protocols developed over decades provided frameworks for detecting artificial signals against natural radio backgrounds. The techniques were sensitive enough to pick up transmissions weaker than cell phone signals across interstellar distances. Yet, the formation produced no detectable radio emissions beyond what thermal processes and solar interaction would naturally generate. If these objects were communicating, they weren't using electromagnetic radiation in frequency ranges human technology could monitor. Optical SETI searches fared no better. Laser communication between the objects, if occurring, should produce brief flashes of coherent light detectable by sensitive instruments watching for artificial signatures. Observatories monitored the formation continuously, looking for pulses, modulated signals, anything suggesting intentional information transfer. The objects maintained their chemical outgassing, their trajectory corrections, their geometric formation, all while apparently maintaining complete radio and optical silence. The communication silence posed several interpretive challenges. Perhaps the technology operated on principles beyond current human understanding, using gravitational waves or quantum entanglement, or exotic physics that left no electromagnetic signature. Perhaps the objects were autonomous, following pre-programmed instructions that required no ongoing communication. Perhaps they had communicated during the months humanity overlooked their presence, and the silence represented mission phases where communication wasn't necessary. Alternatively, the silence might be deliberate concealment. Advanced civilizations capable of interstellar travel would likely understand that electromagnetic emissions propagate at light speed and can be detected across vast distances. Maintaining operational security might require communication protocols that produced no detectable signatures, either through extremely tight beaming that missed Earth entirely, or through technologies that didn't leak electromagnetic radiation into surrounding space. The absence of signals forced uncomfortable recognition that human SETI assumptions might be fundamentally flawed. The search for extraterrestrial intelligence had focused on detecting deliberate signals, messages sent with intent to communicate across interstellar distances. But perhaps advanced civilizations didn't broadcast. Perhaps they had learned that announcing presence carried risks, that silence was survival strategy in a cosmos where not all intelligence was benevolent. The formation's behavior suggested communication was occurring somehow. The coordinated trajectory corrections, the synchronized outgassing patterns, the maintained geometric spacing, all required information transfer between objects separated by millions of kilometers. Light travel time alone across the formation exceeded 3 hours from leading edge to trailing companion. Yet, the coordination happened faster than light-speed communication should allow, either suggesting faster than light capabilities, or pre-planned responses to predicted perturbations. Scientists wrestling with the communication silence began considering that presence itself was the message. 5 objects maintaining impossible formation while transiting a solar system was unmistakable to any civilization with basic astronomy. The silence wasn't absence of communication, but rather a specific type of message. Demonstration without explanation. Presence without engagement. Perhaps humanity was being shown something fundamental about the cosmos, that we share space with intelligence that neither hides completely nor reaches out openly. Intelligence that travels through our system while maintaining deliberate distance. Photometric monitoring campaigns, tracking the formation's brightness over time, revealed patterns that pushed beyond coincidence into territory that demanded explanation. All 5 objects showed periodic variations in reflected sunlight, but the synchronization of these variations suggested coordination that natural rotation couldn't produce. Individual rotating objects naturally show brightness changes as different surface features rotate into and out of view. Bright icy patches and dark rocky regions create periodic signals as the object spins. These variations are unique to each body, determined by rotation rate, surface composition, and shape. No 2 natural objects should show identical brightness patterns unless they were perfectly synchronized in ways that gravity alone couldn't maintain. The 3I Atlas formation showed exactly this impossible synchronization. Brightness measurements, taken simultaneously across all 5 objects, revealed fluctuations that peaked and dipped together with precision measured in minutes. The period repeated every 11.3 hours across the entire formation, suggesting either identical rotation rates, locked to impossible precision, or coordinated surface activity that mimicked rotation signals. The synchronization extended beyond simple periodicity. Fine structure in the brightness curves, subtle secondary peaks, and asymmetries in the light variations appeared identically across multiple objects. Natural processes that might produce synchronized rotation periods through tidal locking require close proximity and millions of years of gravitational interaction. These objects maintained distances of hundreds of millions of kilometers with no mechanism for the tidal forces needed to lock their rotations together. Detailed analysis of the brightness patterns revealed another troubling aspect. The variations didn't match expected signatures from irregular rotating bodies. Natural asteroids and comets show complex brightness curves determined by their irregular shapes tumbling through space. The 3I Atlas formation showed clean sinusoidal variations, smooth rises and falls that suggested either remarkably spherical shapes or artificial modulation of reflected light through controlled surface changes. Spectroscopic observations during brightness, maxima, and minima provided additional clues. The chemical signatures remained constant throughout the brightness cycle, ruling out simple explanations like different surface compositions rotating into view. Whatever caused the brightness changes wasn't exposing different materials, but rather changing reflectivity uniformly across entire surfaces in coordinated fashion. The coordination timing raised questions about information transfer between objects. If the brightness variations represented intentional signaling or synchronized surface modifications, the objects needed to coordinate across light-hour distances. At the formation scale, light travel time between extreme members exceeded 3 hours. Yet the brightness peaks aligned within minutes, suggesting either faster than light coordination or sophisticated prediction algorithms that allowed each object to maintain synchronization without real-time communication. Temperature monitoring added another layer to the mystery. Infrared observations showed thermal variations that matched the optical brightness cycles, but occurred with phase delays that didn't fit passive solar heating. The objects were warming and cooling in patterns that suggested active thermal management rather than simple rotation under sunlight. The brightness synchronization joined the growing list of characteristics that defied natural explanation. Objects separated by vast distances, showing no gravitational binding, were somehow coordinating their reflective properties in lockstep. The behavior suggested either technological control or physical principles human science hadn't discovered. Either option challenged fundamental assumptions about what was possible and what these visitors actually were beneath their comet-like disguises. The gas jets that made the formation visible in the first place, the water vapor and carbon dioxide plumes that allowed classification as active comets, displayed coordination patterns that transformed from curious to impossible as observation precision improved. Multiple observatories monitoring the objects throughout December 2025 documented outgassing events that occurred in synchronized bursts across millions of kilometers of separation. Natural comet outgassing follows predictable patterns driven by solar heating. As sunlight warms the surface, subsurface ice reaches sublimation temperature and vaporizes, creating jets that erupt through weak points in the outer crust. These eruptions are chaotic, triggered by local thermal conditions and structural failures that vary randomly across each object's surface. No two comets should outgas in synchronized patterns unless they experience identical heating at identical moments. The 3I Atlas formation violated these expectations systematically. When spectroscopic monitoring detected water vapor production increasing from the central object, the companion objects showed corresponding increases within 30 to 40 minutes. Carbon dioxide jets that erupted from the flanking escorts appeared in pairs, simultaneous releases from objects separated by 0.8 astronomical units. The statistical probability of this synchronization occurring naturally sat firmly in impossible territory. The timing precision was most troubling aspect. Light travel time across the formation meant that if objects were responding to signals from each other, the coordination delays should match communication lag. A signal from 3I Atlas would take roughly 20 minutes to reach the flanking objects at their separation distance. But the outgassing synchronization showed no such delays. Events appeared simultaneously within measurement precision of a few minutes, far faster than light-speed communication could coordinate. Spectral analysis of the gas composition during synchronized events showed identical molecular ratios across all objects. The same mix of water, carbon dioxide, carbon monoxide, and organic compounds appeared in the same proportions from each source during coordinated outbursts. Natural outgassing reflects local composition at eruption sites, which varies across a comet's surface and certainly between different bodies. This homogeneity suggested either impossible chemical uniformity or controlled release from identical internal reservoirs. The energy release patterns defied thermal models. Solar heating should produce gradual increases in outgassing as surfaces warm, with peak activity occurring hours after maximum solar flux. The synchronized bursts showed no correlation with solar heating cycles. They occurred when formation geometry required, when trajectory corrections needed momentum transfer, or following patterns that suggested operational schedules rather than environmental responses. High-resolution imaging during outgassing events revealed another anomaly. The jets didn't emanate from random surface locations, as natural sublimation should produce. Instead, they appeared from consistent positions that remained active across multiple observation sessions, suggesting permanent vents or nozzles, rather than the temporary fractures in volatile rich ice. The outgassing synchronicity joined trajectory corrections and brightness variations in the catalogue of impossible coordinations. 3 separate observable phenomena, each requiring information transfer or predetermined scheduling across vast distances, all occurring in the same formation of objects. The cumulative improbability exceeded any threshold for coincidence. These objects were operating according to shared instructions or responding to coordinated control in ways that mark them as fundamentally artificial, regardless of their comet-like appearance. The gas jets weren't natural sublimation. They were propulsion or signaling systems masquerading as familiar phenomena. A troubling question emerged as evidence accumulated through December 2025. If formation flying was characteristic of interstellar visitors, why had humanity detected only isolated objects before 3I Atlas? The previous 2 confirmed visitors Oumuamua and 2I Borisov showed no companions despite thorough observation campaigns. Either 3I Atlas represented an anomaly, or detection methods were systematically missing formation members in ways that revealed fundamental blind spots. The paradox cut both ways. If multiple object formations were common, earlier surveys should have detected hints of companions around previous visitors. The fact that Oumuamua and 2I Borisov appeared solitary suggested either they truly travelled alone, or their companions remained undetected due to observational limitations. Neither option provided comfort. The first implied 3I Atlas was unique. The second implied a systematic failure to recognize what was actually transiting human space. Astronomers began re-examining archival data from previous interstellar detections with new awareness. Oumuamua had puzzled researchers with its anomalous acceleration, non-gravitational forces that couldn't be explained through conventional outgassing, because the object showed no visible coma or tail. Multiple theories emerged, ranging from hydrogen icebergs to light sails. But what if the acceleration came from unseen companions, objects travelling in formation that provided thrust or gravitational assists too subtle to attribute correctly? The reanalysis revealed tantalizing hints that had been dismissed during initial investigation. Oumuamua's trajectory showed micro variations that didn't fit pure gravitational models perfectly. The deviations were small enough to attribute to measurement uncertainty or unmodelled forces, but they occurred at intervals that might suggest periodic interactions with nearby objects. Without knowing to look for formation members, analysts had reasonably attributed these variations to data noise. 2I Borisov presented different challenges. As an active comet with visible coma, any companions would have been hidden in its glare unless specifically targeted by observation campaigns. The surveys that discovered and tracked 2I Borisov optimized for detecting the primary object, not searching for fainter escorts in its vicinity. Standard image processing techniques removed diffuse background features to highlight the comet nucleus, potentially erasing evidence of companion objects in the discarded data. The detection bias extended beyond individual cases to survey design itself. Automated detection systems flagged isolated bright objects moving against background stars, formation flying objects, especially when brightness hierarchies made some members orders of magnitude fainter than others, might register as single detections with unusual morphology rather than multiple distinct targets. The algorithms optimized for finding individual objects systematically overlooked what they weren't programmed to recognize. This realization prompted urgent updates to detection protocols. Observatories began implementing companion search procedures around all objects of interest, looking specifically for faint escorts that might accompany brighter primaries. Archival surveys received new processing passes designed to reveal formation structures rather than isolated sources. The Vera Rubin Observatory, soon to begin operations, incorporated formation detection into its design parameters from the start. The detection bias paradox suggested a humbling possibility. Humanity might have been observing formation flying interstellar visitors all along without recognizing them as such. The previous classifications of Oumuamua and 2I Borisov as solitary objects might reflect observation limitations rather than physical reality. 3I Atlas forced recognition that seeing required knowing what to look for, and the cosmos might be far more populated and active than detection statistics suggested. Precision Doppler measurements, tracking radial velocities of the formation objects, revealed micro-accelerations that violated fundamental physics principles. The changes were subtle, measured in millimeters per second over observation periods spanning weeks, but their characteristics defied explanation through any known force or mechanism. Conservation of momentum, one of physics' most sacred laws, appeared to be breaking down. The anomalies first appeared in data from multiple observatories, cross-checking their velocity measurements for consistency. When spectroscopic observations from different facilities were compared, tiny discrepancies emerged that exceeded instrument precision. The objects were accelerating in ways that shouldn't be possible, gaining or losing velocity without corresponding reaction mass or energy expenditure that observers could detect. Natural forces acting on objects in space leave characteristic signatures. Solar radiation pressure produces acceleration away from the Sun proportional to surface area and inversely proportional to mass. Outgassing creates thrust vectors aligned with jet directions. Gravitational perturbations from planets produce velocity changes that correlate with planetary positions and masses. The anomalous accelerations matched none of these patterns. Most troubling were the momentum budget violations. When an object accelerates, it must push against something, expelling mass or energy to produce reaction force. Rocket engines burn fuel and expel exhaust. Solar sails push against photons. Even exotic propulsion concepts like ion drives or nuclear pulse systems obey momentum conservation through measurable emission of particles or radiation. The formation objects accelerated while producing nothing detectable. The velocity changes occurred in directions that made operational sense rather than physical sense. When formation spacing needed adjustment, objects accelerated toward or away from their companions at magnitudes perfectly calibrated to restore geometry. When gravitational perturbations threatened to distort the pattern, compensating accelerations appeared that exactly counteracted the disturbance. The precision suggested active feedback control rather than passive response to natural forces. Energy accounting made the situation more impossible. The cumulative velocity changes observed across all 5 objects over 2 months of monitoring represented kinetic energy exceeding 10 to the 16th joules. That energy had to come from somewhere. Chemical fuel would require masses greater than the objects themselves. Nuclear reactions would produce detectable radiation. Solar collection would need arrays far larger than observed dimensions. No visible energy source could account for the observed momentum changes. Temperature measurements during acceleration events showed no anomalies. Objects undergoing propulsive maneuvers should show thermal signatures from energy conversion processes. Rocket engines produce heat. Solar panels warm under sunlight. Nuclear reactors radiate waste thermal energy. The formation objects maintained temperatures consistent with passive solar heating during periods when they were clearly accelerating through unknown means. The velocity anomalies represented more than measurement puzzles. They challenged physics at fundamental levels. Either these objects possessed propulsion technology that violated conservation laws as humans understood them, or they operated through physical principles that current theory couldn't describe. Both options were deeply uncomfortable for scientific communities built on centuries of validated physical law. Alternative explanations, invoking measurement error or systematic biases, couldn't account for the consistency across independent observatories. using different instruments and techniques. The anomalies were real, reproducible, and impossible, according to established physics. The formation wasn't just traveling through space using conventional means hidden from detection. It was demonstrating capabilities that suggested either revolutionary technology or gaps in human understanding of how momentum and energy actually work at scales relevant to interstellar travel. High-resolution imaging campaigns in mid-December 2025 revealed structure in the space between formation objects that transformed from barely detectable signal into compelling evidence for physical connection. A tenuous bridge of material stretched across the formation, linking the objects through filaments so faint they required careful image stacking and processing to visualize. The question was whether this represented natural debris field or something more organized. The discovery came from combining hundreds of exposures from multiple telescopes, using techniques developed for detecting faint nebulosity around distant galaxies. When applied to the space surrounding 3I Atlas, these methods revealed wispy structures connecting the primary object to its companions. The material was extraordinarily diffuse, perhaps 1 particle per cubic meter, but it followed paths that were distinctly non-random. Natural debris clouds around comets spread spherically or in comet-shaped distributions determined by outgassing patterns and solar radiation pressure. The material forms diffuse halos and tails that point away from the sun, following well-understood physical principles. The structure around the 3I Atlas formation showed linear features connecting specific objects, tendrils of dust that maintained coherence across distances where dispersion should have scattered them into invisibility. Spectroscopic analysis of the dust bridge material showed composition matching the objects themselves. Silicate, particles, organic compounds, water, ice grains, all present in proportions that suggested origin from the formation members, rather than swept up interstellar material. But the particle size distribution was unusual, peaked around specific diameters that suggested sorting or selection, rather than natural fragmentation processes that produce power law distributions across all sizes. The geometry of the bridge structure raised the most questions. The densest concentrations appeared along straight-line paths between objects, particularly connecting the flanking escorts to the central 3I Atlas. Natural orbital mechanics doesn't produce straight-line features in space. Material released from one object and drifting toward another follows curved trajectories determined by gravitational influences and initial velocities. These bridges showed linearity that implied active maintenance or recent formation. Polarization measurements of sunlight scattered by the dust provided clues about particle alignment. Natural dust clouds show random grain orientations, producing unpolarized scattered light. The bridge material showed preferential alignment, suggesting either magnetic fields organizing the particles or systematic forces acting on the grains to maintain specific orientations. Either explanation required active processes beyond simple gravitational and radiation forces. Time series observations tracked the bridge evolution over weeks. Rather than dispersing as natural debris should, the structures maintained coherence. New material appeared to be continuously supplied from the objects, replacing particles lost to solar radiation pressure and maintaining the connecting filaments despite forces that should scatter them. The bridges were being actively sustained through mechanisms that weren't immediately obvious. The functional interpretation was unavoidable. If the formation represented artificial constructs, the dust bridges might serve as physical connections, tethers, or communication pathways, linking the objects through material means rather than electromagnetic signals. The particles might carry information through their organized structure, or provide physical medium for energy or resource transfer between formation members. Alternatively, the bridges might represent exhaust or byproduct from whatever propulsion system maintained formation geometry. The dust could be deliberate camouflage, material released to enhance the comet-like appearance, while serving engineering functions that made formation coordination easier. The particles might even be sensors, distributed throughout the formation volume to monitor local space conditions. As December 2025 progressed toward the formation's closest approach to Earth, astrobiologists and planetary scientists began developing a hypothesis that reframed everything. Perhaps the formation wasn't exploration or military patrol, but something more fundamental to life's propagation across the galaxy. Perhaps humanity was witnessing an ancient terraforming convoy, planetary seeding equipment traveling established routes between stellar systems to distribute the building blocks of life. The concept had deep roots in astrobiology. Panspermia theories suggested life might spread through space via natural processes, bacterial spores, or organic molecules, hitching rides on comets and asteroids ejected from living worlds. But directed panspermia proposed something more intentional: advanced civilizations deliberately seeding promising planets with genetic material, or even engineered ecosystems to accelerate biological development across the cosmos. The 3I Atlas formation fit this scenario with unsettling precision. The massive central object could serve as primary cargo vessel, carrying billions of tons of biological precursors, genetic templates, or even cryopreserved organisms intended for deployment on target worlds. The enormous mass that had puzzled observers became necessary storage for seeding materials, meant to transform barren planets into living ecosystems. The chemical composition supported biological cargo interpretation. The water ice, organic compounds, and carbon dioxide enrichment weren't just natural volatile signatures, but rather optimal preservation medium for biological material traveling across interstellar distances. Water provided radiation shielding and temperature buffering. Organic molecules offered chemical building blocks. The exotic volatile ratios might represent engineered mixtures optimized for maintaining biological viability rather than natural formation signatures. The escort objects took on specific functional roles under seeding fleet hypothesis. The leading pathfinder could be assessing stellar systems ahead, identifying planets with appropriate conditions for biological seeding, measuring atmospheric compositions and surface temperatures to determine deployment strategies. The flanking escorts might serve as secondary cargo vessels or processing facilities that prepared seeding materials for specific target environments. The trajectory through human solar system suggested reconnaissance rather than deployment mission. The formation wasn't slowing to orbit or releasing payloads toward Earth or other planets. It was passing through, gathering data about stellar system characteristics, planetary compositions, presence or absence of existing biospheres, perhaps cataloguing which worlds were already inhabited, which remained candidates for future seeding operations. This interpretation transformed the formation from threat or mystery into something more profound. If civilizations spanning the galaxy had developed systematic programs for distributing life, for accelerating biological and potentially technological development across promising worlds. Then Earth itself might be product of earlier seeding missions. Humanity could be looking at the continuation of processes that started life on this planet billions of years ago. The implications for human origins were staggering. Every living thing on Earth, from bacteria to humans, might trace ancestry, not just to terrestrial evolution, but to deliberate seeding by intelligence that achieved interstellar capability before Earth's sun even formed. The formation passing through our solar system wasn't first contact, but rather a reminder that contact had occurred long ago in forms humanity never recognized. The seeding fleet hypothesis explained coordination and mass while providing purposeful framework for understanding the formation's behavior. These weren't weapons or invasion forces, but gardeners operating on galactic scales, tending the cosmic ecosystem through patient processes spanning millions of years. The silence made sense. There was nothing to communicate to newly emerged civilizations, not yet ready to join the seeding programs themselves. A radical reinterpretation of the formation's significance emerged from galactic dynamics modeling. Perhaps 3I Atlas and its escorts weren't isolated visitors, but travelers on established routes, following pathways through the galaxy that connected stellar systems through networks unknown to humanity. The formation might represent traffic rather than exploration, routine transit along interstellar highways that had existed for millions or billions of years. The concept started with trajectory analysis, when researchers extrapolated the formation's path backward into the galaxy, accounting for stellar motions and gravitational influences over millions of years. The vector pointed toward a specific region of space, containing several dozen stars within 30 light-years of each other. Forward projection showed the path aimed toward another stellar cluster, roughly 50 light-years from the Sun. The trajectory wasn't random wandering, but appeared to connect specific destinations. This observation sparked systematic searches for other objects that might be following similar paths. Astronomers began examining archival data from asteroid and comet surveys, looking for objects with unusual velocities or trajectories that didn't fit solar system origin. Within weeks, 3 candidates emerged, small objects moving on paths roughly parallel to the 3I Atlas formation, but offset by months or years in timing. These hadn't been recognized as interstellar because their velocities barely exceeded solar escape speed, but their trajectories aligned with the highway hypothesis. The implications transformed understanding of galactic structure. If civilizations established travel routes between stellar systems, they would choose paths that minimized transit time while avoiding hazards like dense molecular clouds or regions with high supernova risk. The routes would connect stars with characteristics favorable for life or resource extraction, creating networks that linked habitable zones across vast distances. 3I Atlas might be following one branch of this network. Traffic flow along established routes explained why multiple objects appeared together. Highways weren't empty. They carried vehicles traveling at different speeds and schedules, but following the same basic path. The formation might have launched from its origin system years or decades after other travelers departed, catching up or being overtaken during the journey. What humans saw as unprecedented multiple object detection might be normal traffic density along busy routes. The highway model also explained why detection was so recent. Human astronomy had only developed sensitivity to detect faint interstellar objects within the last few years. If one or more major routes passed through or near the solar system, traffic would have been flowing past Earth unnoticed throughout human history. The last decade's detections, Oumuamua, 2I Borisov, 3I Atlas with its escorts, might represent typical traffic volume, now finally visible to improved observational capabilities. This realization suggested the galaxy was far more active and connected than isolation assumptions implied. Rather than vast empty spaces separating isolated stellar systems, the volume between stars might be crisscrossed with established pathways carrying continuous streams of travelers. Earth existed not in cosmic wilderness, but near the equivalent of galactic transit routes, watching traffic pass that had always been there but remained invisible until technology advanced sufficiently. The interstellar highway hypothesis recast humanity's cosmic context entirely. Rather than rare visitors stumbling through an empty void, observers were witnessing routine operations along infrastructure networks spanning the galaxy. The question became not whether intelligence existed elsewhere, but how to recognize and eventually access the transportation systems connecting inhabited worlds across thousands of light years of traveled space. A sobering realization emerged from analyzing detection statistics and technological capabilities. Human astronomy might be systematically selecting for specific types of interstellar objects while missing entire categories that didn't fit observational biases. The 3I Atlas formation's characteristics, its size, brightness, and activity level, made it detectable. But what population of objects remained invisible because they didn't match the profiles current surveys were designed to find? Detection methods favored large, active, reflective objects. Survey telescopes scanned for moving sources that appeared bright against background stars. Spectroscopy required sufficient light to analyze. Size estimates depended on visible coma and outgassing activity. Every aspect of discovery pipeline selected for objects that announced their presence through properties human instruments could measure. Stealth objects, dark objects, or inactive objects would pass through the solar system completely unnoticed. The formation itself demonstrated this bias. The companion objects remained undetected for months, despite being captured in numerous images because they sat below attention thresholds. Only after their presence was suspected did targeted searches reveal them. How many other objects traveled through unrecognized because no one knew to look, because detection algorithms filtered them as noise or artifacts, because they didn't match templates of what interstellar visitors should resemble. Size bias particularly troubled researchers. The massive scale of 3I Atlas made detection easier, its brightness and activity visible across vast distances. Smaller objects, even if numerous, would be proportionally fainter and harder to spot. Survey completeness calculations suggested current capabilities detected perhaps 10% of 1 kilometer objects passing through the inner solar system. For 100-meter scale objects, detection rates dropped below 1%. Anything smaller remained effectively invisible. Velocity selection added another bias layer. Objects moving too slowly might be mistaken for distant solar system bodies. Objects moving too quickly might streak through detection fields before automated systems recognize them as real rather than cosmic ray artifacts. The window of detectable velocities represented only a fraction of of possible interstellar approach speeds. Traffic moving outside this window would go unrecognized, regardless of size or brightness. Temporal bias affected long-term statistics. Humanity had been capable of detecting interstellar objects for less than a decade. The sample size of 3 confirmed detections represented an absurdly small statistical basis for drawing conclusions about populations, frequencies, or typical characteristics. Drawing general principles from 3 examples was like trying to understand Earth's biodiversity from 3 random species encountered during a brief walk. The observer effect suggested a humbling possibility. Everything astronomers thought they understood about interstellar objects, their sizes, compositions, frequencies, and behaviors, derived from severely biased sample affected by technological limitations and assumptions built into detection methods. The actual population passing through might be orders of magnitude larger, more diverse, and more exotic than the few examples technology happened to catch. This recognition demanded acknowledging ignorance rather than claiming understanding. The formation wasn't necessarily representative of typical interstellar visitors. It was representative of detectable visitors, given current capabilities. The true nature of traffic through the solar system remained unknown, hidden behind observational selection effects that filtered reality through narrow windows of what current astronomy could actually see. Humanity was watching ships pass, but missing the full fleet because vision remained limited to specific wavelengths, brightnesses, and behavioral profiles that represented only a fraction of what actually traveled the space between stars. Behind closed doors throughout December 2025, government officials and military advisors wrestled with questions that had no precedent in human history. If the formation represented artificial constructs under intelligent control, what threat did they pose? What defensive measures could humanity implement against technology capable of crossing interstellar distances? And most fundamentally, should demonstrating defensive capability itself be considered a hostile act that might provoke response? The security assessment started with capability analysis. Any civilization that achieved interstellar travel possessed energy manipulation and propulsion technology far exceeding human capabilities. The formation's ability to maintain coordination across vast distances, execute trajectory corrections without visible propulsion, and potentially violate conservation laws as humans understood them, suggested technological sophistication measured in centuries or millennia beyond current terrestrial achievement. Military planners faced uncomfortable mathematics. The kinetic energy of a 1-kilometer object moving at even modest interstellar velocities exceeded all nuclear weapons on Earth combined. If any formation member diverted toward a terrestrial impact, no defensive system could intercept or deflect it. Detection would provide months of warning, but 0 defensive options. Humanity possessed no weapons or capabilities relevant to defending against objects that size and velocity if they chose aggressive action. The formation's trajectory provided minimal reassurance. Closest approach to Earth occurred at 1.8 astronomical units, roughly 170 million kilometers. Comfortable distance by any measure, but well within range for objects demonstrating active maneuvering capability. If intentions changed, if orders came from unknown sources to investigate Earth more closely or eliminate potential competitors, the formation could redirect toward inner solar system faster than humanity could mount any response. Strategic doctrine developed for terrestrial conflicts, offered no applicable frameworks. Concepts like deterrence assumed capability for mutually assured destruction. Humanity possessed no retaliatory capability against interstellar visitors. Defensive strategies assumed ability to intercept or destroy incoming threats. Current technology couldn't touch objects moving at dozens of kilometers per second with unknown defensive capabilities. Every military principle relied on rough parity, or at least measurable capability, that simply didn't exist in this scenario. Some advisors argued for demonstrating technological capability, launching missions toward the formation to show humanity possessed spacefaring technology, even if primitive by visitor standards. Others warned this could be interpreted as hostile reconnaissance or probe for weaknesses, potentially triggering defensive responses. The debate revealed how communication without shared context or protocols carried risks that might dwarf any benefits. International coordination became critical concern. Nuclear weapon agreements and space treaties assumed terrestrial actors as only relevant parties. The formation's presence demanded unprecedented global cooperation on questions of response protocols, communication attempts, and defensive postures. Nations that couldn't agree on climate policy or trade regulations needed to present a unified front on issues of species-level significance. The uncomfortable conclusion across all security assessments was that defense in traditional sense was impossible. Humanity couldn't protect itself against civilization, demonstrating this technological capability if they chose hostile action. The only viable strategy was hoping peaceful intent, maintaining observational awareness, and avoiding actions that might be interpreted as threatening. Earth's defense against interstellar visitors wasn't military, it was behavioral. Don't provoke what you cannot fight. Don't threaten what you cannot understand. And hope that intelligence capable of crossing light years possessed wisdom proportional to its technology. The formation's passage forced fundamental reassessment of humanity's search for extraterrestrial intelligence. Decades of SETI efforts had focused on detecting deliberate signals, radio transmissions or laser pulses meant to announce presence and initiate communication. But if advanced civilizations routinely traveled through space while maintaining electromagnetic silence, if intelligence manifested through physical presence rather than broadcast messages, then the entire search strategy required rethinking from foundational assumptions upward. Traditional SETI operated on optimistic premises about how intelligence would behave. Advanced civilizations would want contact, would broadcast greetings or beacons to help younger species find them, would use electromagnetic spectrum because it offered efficient long-distance communication. These assumptions made sense from human perspective, but perhaps revealed more about terrestrial thinking than universal principles of how intelligence actually operated across galactic scales. The formation suggested alternative model. Intelligence that achieved interstellar capability might value operational security over open communication. Broadcasting location and capabilities into cosmos might attract unwanted attention from civilizations with hostile intent or resource competition motives. Silence could be survival strategy, learned wisdom accumulated from species that announced themselves too loudly and suffered consequences. The quiet galaxy wasn't empty, it was cautious. This realization demanded new detection strategies. Rather than listening for signals, SETI needed to watch for unexplained objects, trajectory anomalies, or physical presence that defied natural explanation. The search shifted from communication to observation, from waiting for messages to actively hunting for visitors that deliberately avoided announcing themselves. Every astronomical survey became potential SETI platform if analysts knew what characteristics marked artificial constructs disguised as natural objects. The mass discrepancy became diagnostic signature. Natural objects followed predictable mass to activity ratios. Violations of these ratios, bodies showing wrong densities or acceleration characteristics, marked potential artificial constructs regardless of their comet or asteroid appearance. The formation had been screaming artificial through its physics while maintaining radio silence. The message was in behavior, not broadcasts. Synchronized phenomena across multiple objects provided another detection criterion. Natural processes produced random variations. Coordinated brightness changes, simultaneous outgassing, maintained geometric formations, all indicated active control, even without electromagnetic emissions. SETI could search for these patterns in archival data, looking for formation flying objects that passed unrecognized because observers weren't watching for coordination signatures. The recalibration extended to assumptions about contact intentions. Perhaps advanced civilizations didn't want conversation with newly emerged species. Perhaps they operated under non-interference principles, observing developing worlds without engagement until those worlds achieved certain technological or ethical thresholds. The formation's passage through inner solar system could be reconnaissance, data gathering about Earth's status without initiating contact that might disrupt natural development. This hypothesis explained the communication silence while acknowledging presence. Intelligence crossing the galaxy didn't need humanity's permission or awareness. They gathered information through observation while maintaining distance that prevented disruption or premature contact. Earth was being catalogued, studied, perhaps evaluated against criteria humanity couldn't guess, all without overt interaction that traditional SETI expected. The implications transformed humanity's cosmic status. Rather than alone and searching, Earth existed under observation by intelligence that chose when and whether to acknowledge the search. The question wasn't whether intelligence existed elsewhere, but whether humanity had developed sufficiently to warrant open contact. The formation passing through might be test, evaluation of how emerging civilization responded to evidence of advanced visitors operating in their space. Every human reaction, every defensive consideration, every communication attempt became data points in assessment processes that would determine if and when actual contact occurred. As calendar year 2025 drew to a close, the astronomical community found itself divided into increasingly hostile camps over interpretation of the formation data. What began as scientific debate escalated into professional warfare that threatened careers and fractured institutional relationships built over decades of collegial cooperation. The conservative faction maintained that extraordinary claims required extraordinary evidence. While acknowledging the formation's unusual characteristics, they insisted natural explanations remained viable until completely exhausted. Every unusual observation, from mass discrepancies to trajectory corrections, could potentially be explained through undiscovered natural processes or systematic measurement errors not yet identified. Declaring the objects artificial without definitive proof violated scientific principles that demanded skepticism as default position. The alternative interpretation faction argued that cumulative improbability of natural explanations exceeded any reasonable threshold. When every conventional hypothesis failed, when statistical analyses returned impossible coincidence factors, when multiple independent lines of evidence all pointed toward artificial origin, refusing to acknowledge that conclusion became willful blindness rather than appropriate skepticism. Science required following evidence even when implications were uncomfortable. The conflict played out through journal submissions, conference presentations, and increasingly personal attacks on social media platforms. Papers proposing artificial origin faced rejection from editorial boards dominated by conservative reviewers. Counterpapers defending natural explanations received immediate acceptance despite weaker statistical arguments. Career advancement opportunities dried up for researchers on wrong side of institutional biases, regardless of data quality supporting their positions. Junior scientists faced impossible choices. Taking strong positions on controversial interpretations risked alienating senior colleagues who controlled funding, tenure decisions, and publication opportunities. But remaining neutral meant missing potential involvement in most significant astronomical discovery in human history. Graduate students watched their advisors engage in professional combat while trying to determine which camp offered better career prospects versus which interpretation the evidence actually supported. The firestorm revealed how human institutions struggled when confronting questions outside normal operational parameters. Science built methodologies for incremental progress, testing hypotheses through controlled experiments, building consensus through reproducible results. But the formation offered no controlled conditions, no reproducible experiments, only observations of unique event that would never repeat exactly. The standard processes weren't designed for this situation, and their failure created vacuum filled by politics, personalities, and professional survival instincts rather than dispassionate evaluation of evidence. On January 5th, 2026, Pranobo coordinated international announcement acknowledged what scientific communities had been debating privately for months. Government officials, space agency directors, and senior astronomers from 23 nations participated in simultaneous press conferences, presenting unified assessment of the formation. The carefully crafted statement walked delicate line between transparency and panic prevention. The official position acknowledged 5 objects traveling in coordinated formation through the solar system. It presented evidence for trajectory corrections, mass anomalies, and synchronized behaviors that defied natural explanation through currently understood processes. It stopped short of declaring artificial origin, instead using phrases like unprecedented characteristics and requiring further investigation to describe observations that clearly suggested intelligence. The public response split along predictable lines. Some celebrated what they interpreted as confirmation of extraterrestrial visitation, validation of beliefs that humanity wasn't alone in cosmos. Others dismissed the announcement as misinterpretation of natural phenomena, insisting scientists were seeing patterns where only coincidence existed. Religious communities debated theological implications, while conspiracy theorists claimed governments were hiding more dramatic truths behind measured official statements. Financial markets reacted with surprising stability. Initial volatility settled within days, as analysts concluded the formation posed no immediate economic threat. Defense stocks rose modestly on speculation about increased space surveillance spending. Space industry companies saw investor interest based on potential technology applications if artificial origin was eventually confirmed. The formation became normalized risk factor rather than civilization-ending crisis. Educational institutions struggled with how to present the information. Science curricula suddenly needed updating to include interstellar object detection and artificial versus natural classification criteria. Teachers faced classrooms full of students asking questions that had no definitive answers, demanding certainty about topics where even experts remained divided. The formation became teaching opportunity about scientific uncertainty and how knowledge develops through iterative refinement rather than sudden revelation. Media coverage gradually shifted from sensationalism toward more nuanced reporting as initial shock wore off. The formation wasn't attacking, wasn't communicating, was simply passing through on trajectory that would carry it back to interstellar space by mid-year. The story evolved from crisis to mystery, from immediate threat to long-term question about humanity's place in potentially populated cosmos. Public consciousness began adapting to new reality where objects of unclear origin could transit human space while maintaining deliberate distance that prevented definitive classification. Every major observatory on Earth redirected resources toward the formation during the first months of 2026. The Coordinated Observation Campaign represented unprecedented scientific mobilization, with facilities normally competing for discovery priority, now sharing data in real time to maximize information gathered before the objects departed beyond detection range forever. Space-based assets received priority tasking. Hubble allocated additional observation windows despite oversubscribed schedule. James Webb cleared entire weeks for continuous spectroscopic monitoring. Even planetary missions in deep space turned instruments toward the formation when geometry allowed, providing observation angles impossible from Earth orbit. The campaign aimed to extract every possible data point before opportunity vanished. Ground observatories organized continuous coverage as Earth's rotation carried different facilities into optimal viewing positions. When European telescopes lost the formation below horizon, facilities in Chile picked up observations. As South American sites rotated out of range, Hawaiian and Asian observatories continued monitoring. The sun never set on formation surveillance during critical observation periods surrounding closest approach. Amateur astronomers contributed valuable data despite limited equipment. Thousands of backyard telescopes tracked the objects, providing position measurements that refined orbital calculations and detected subtle variations. Professional facilities might miss between scheduled observations. Distributed observation networks proved that citizen science could meaningfully contribute to questions of cosmic significance when coordination and data sharing protocols were properly implemented. The campaign yielded unprecedented dataset covering electromagnetic spectrum from radio through gamma rays. Every wavelength, every possible observation technique, every available instrument focused on squeezing maximum information from fleeting opportunity. Researchers understood this might be only chance in human lifetime to study interstellar visitors at relatively close range with current technology. Results refined rather than resolved key questions. The mass estimates held up under additional scrutiny. Trajectory corrections continued following patterns consistent with active control. Chemical homogeneity remained unexplained through natural processes. Each new observation added detail without fundamentally changing the puzzle's nature. The formation was behaving exactly as initial analysis suggested, coordinated and controlled, regardless of whether observers labeled that conclusion artificial or simply unexplained. By late February 2026, the formation was accelerating outward toward escape velocity that would carry it back to interstellar space. The observation window was closing. Soon, the objects would fade beyond detection limits of even the most powerful telescopes, carrying their secrets back into cosmic void while leaving humanity with more questions than answers. As the formation faded from telescopic view during spring 2026, astronomers compiled lists of what remained unknown despite months of intensive observation. The catalogue of unanswered questions exceeded the list of confirmed facts, revealing how little humanity actually understood about what had passed through its cosmic neighborhood. The origin question topped every list. Where had these objects come from? Trajectory extrapolation pointed toward general regions of space, but couldn't identify specific stellar systems. Were they launched from planets orbiting nearby stars within 50 light-years? Or had they traveled thousands of light-years from distant galactic regions? The travel time implications ranged from thousands to millions of years, depending on origin distance, fundamentally affecting interpretation of purpose and technology. The propulsion mechanism remained completely mysterious. The objects executed trajectory corrections without detectable exhaust, energy expenditure, or reaction mass. Either they possessed technology that violated conservation laws as humans understood them, or they operated through physical principles current science couldn't describe. Both options suggested capabilities far exceeding terrestrial achievement. But neither explanation could be tested or verified with available data. The purpose question generated endless speculation, but zero definitive answers. Were these scientific probes studying stellar systems? Planetary seeding equipment distributing biological materials? Military patrol vessels monitoring galactic territories? Commercial transport following established trade routes? Survey missions cataloging habitable worlds? Every hypothesis fit some observations while failing to explain others. Without communication or additional context, purpose remained pure speculation. The population question troubled statisticians. Was this formation typical of interstellar traffic, or rare exception? Did similar groups pass through regularly but remain undetected? Were there thousands of these formations transiting the galaxy at any moment? Or had humanity witnessed genuinely unusual event? The detection statistics were too limited to draw meaningful conclusions about frequencies or typical characteristics. The intelligence question cut deepest. If these were artificial constructs, what kind of minds created them? Biological beings using technology, artificial intelligence following ancient programming, post-biological entities transcending categories humans could understand. The objects demonstrated capability without revealing nature of the intelligence directing them. Were creators still monitoring their creations, or had these become autonomous legacy systems operating long after their builders disappeared? The communication silence perhaps represented the most frustrating unanswered question. Why no response to human attempts at contact? Was Earth considered too primitive for engagement? Were non-interference protocols preventing interaction? Or had the objects simply not noticed humanity's signals amid cosmic background noise? By summer 2026, the formation had crossed beyond Neptune's orbit, fading into the darkness from which it emerged. The objects maintained their geometric precision, even as distance reduced them to barely detectable points of light in the most powerful telescopes. They were leaving, returning to interstellar space along trajectories that would carry them toward stellar regions humanity could observe, but never reach with current technology. But something fundamental had changed in how humanity viewed the cosmos. The comfortable assumption of isolation, the belief that Earth existed in empty wilderness between distant islands of potential intelligence, collapsed under weight of evidence that space between stars was neither empty nor unpopulated. The formation had demonstrated that objects, possibly intelligence, traveled through the galaxy, maintaining presence that human civilization was only beginning to detect. Observatories worldwide continued monitoring programs established during the crisis. New surveys designed specifically to detect formation flying objects went online. Detection algorithms incorporated lessons learned about companion objects and coordinated behavior. The astronomical community prepared for future visitors with awareness that what passed once would pass again, that Earth sat not in cosmic isolation, but along routes that carried traffic humanity was learning to recognize. The psychological impact rippled through global consciousness in ways both subtle and profound. Humanity knew it was being watched, catalogued, perhaps evaluated by intelligence that chose observation over engagement. Every achievement, every conflict, every decision about planetary stewardship occurred under potential scrutiny from civilizations whose capabilities and intentions remained unknown. The formation had transformed humanity from cosmic orphan into observed species, aware that others knew of Earth's existence, even if they chose not to acknowledge the knowing. Young astronomers entering the field carried different assumptions than their predecessors. They prepared careers expecting regular interstellar visitor detections rather than rare anomalies. They developed methodologies assuming active galaxy rather than empty void. The formation had shifted paradigms, transformed the field from searching for life elsewhere into documenting life that clearly already existed and operated throughout galactic volume. As the formation disappeared beyond detection limits in late 2026, humanity settled into new reality. The objects were gone, but their implications remained. Earth existed in cosmos, where others traveled, where intelligence moved through space on missions humanity couldn't comprehend. That Pearl watchers had been watched, and both sides knew the isolation was over. The question now was what came next.